Welcome. In this section, we're going to take a look at what is called a 5-number summary of a data set, and then learn to graphically display that information using what's called a box and whisker plot. So all of this is part of exploratory data analysis, which is our first step in just really trying to see what kind of story the data is trying to tell us. So we look for patterns or trends, and we'll return to the idea of outliers as well. But let's first jump in here with identifying the quartiles of a data set. So quartiles, Q1, Q2, Q3. So the first quartile, second quartile, third quartile separates a data set into 4 equal parts. So we'll be looking at an example here where it says the following are the times spent on hold in minutes for a sample of 20 customers phoning a technical support line. So I've got the data put in ascending order for us. So we do need to have our data in order to discuss the quartiles. So the 3 quartiles, Q1, Q2, Q3, so on this picture. So separating data into 4 equal parts. So if I had the smallest value, in our case, it will be 6, and then our largest value, 28, we're going to be finding these quartiles that separate the data into 4 equal parts. So 25% of the data in each of these regions. So the first quartile, it's also called the lower quartile, there would be approximately 25% of the data below it. The second quartile would have approximately 50% of the data below it. So another name for the second quartile was our median that we learned earlier. So the median, the middle of the sorted list of data. And then Q3, the third quartile, about 75% of data would be below it. So that's also called the upper quartile. So quartiles also have equivalents in percentile version here, but we will discuss quartiles generally Q1, Q2, Q3 as we move forward. All right, and then I'll return to interquartile range in a bit, but let's first just start with our data set and finding quartiles. So what we'll do here with our 20 customers, what we'll do first is just find the median, so the middle of the list. So if I count over 10 numbers, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, the median is between the 2 middle numbers. So remember, when there was an even number of values, the median will be between the 2 middle numbers. So in this case, it would be there. So that's our median, and that's also called Q2, the second quartile. So let me find that value. So we're just going to average those 2 middle numbers. So add and divide by 2. That will be 26 divided by 2, or 13. Okay, so we've got 10 numbers to the left of it and 10 numbers to the right of the median. So to find the first quartile, all we have to do is find the middle of the values that are to the left of the median. So I've got 10 values. So if I count over 1, 2, 3, 4, 5, the median of that left side of the median group of data, so the middle of that list will be our Q1, and that's between 9 and 11. So I'll do the math over here. So we're just averaging the 2 middle numbers. That will be 20 divided by 2, or 10. All right, and then Q3, we just find the middle of those 10 numbers to the right of the median, and that will be between the 20 and the 24. That's our third quartile. So we'll just average 20 and 24. All right, in this case, that will be 44 over 2, or 22. All right, so the 5-number summary of a data set consists of these 5 values in this order. So we start with the minimum, and I'm just going to write L for the lowest. The minimum was 6. So we start with writing the smallest value, and then Q1, 10. Our Q2 was 13. Our Q3 was 22. And our maximum up here, 28 minutes on hold. So time spent on hold. All right, so on my dot plot that I've drawn, so the dot plot or the line plot, remember each dot just represents a data value. And I've identified here my Q1, my Q2, and my Q3. So we're going to talk about the interquartile range. So first, let's just point out that 25% of the data is in each of these regions created by the quartiles. So in our case of having 20 data values, I've got 5 numbers in each of those regions. So if we look at our Q1, I'm going to box around it, and our Q3 there, between Q1 and Q3 would be 50% of the customers. So between Q1 and Q3, between Q1 and Q3, I've got 10 customers. So the middle 50%. The interquartile range is the range of that middle 50% of our data. So we'll write the formula down here and we'll abbreviate as well. So interquartile range, we'll call it the IQR. It's just the difference between the third quartile and the first quartile. So in our case, 22 minus 10, that is a difference of 12. And I'll put units just to remind us we're talking about time on hold. So there was a 12-minute spread for that middle 50% of data. Okay, so graphically displaying the 5-number summary, it's called a regular box plot. It's also called a box and whisker plot. You'll see why the whiskers come into play here. So here's what we do. So our new graph. What we'll do is start with Q1 and Q3, and those will form the sides of our box. So we have our number line here, and at Q1, which was 10, I'm just going to draw a line. And at Q3, 22, draw a line there. So that makes up the left and right sides of the box. So I'm going to add here what I'm doing on the top. Generally, we wouldn't have to label it Q1 because people will know that once we've learned to do some box plots. But as we're learning it for the first time, I'm going to label more information. So Q1 is the left side of the box. Q3 is the right side of the box. So the length of that box is 12 minutes. So the length is the IQR, the interquartile range. Just make sure when you draw your box, we hover it above the number line. We don't want to write on top of our number line. We want to make sure it's really clear when people look at our graph. And then we move on to our Q2. So the median, the middle value, was 13. So Q2 was 13. So we're going to draw a line inside of our box here at 13. So our Q2, or our median. And so now what I know is 25% of our data, and 25% of our data is contained in the box, and it's separated in that way. So I'm going to go ahead and also actually draw the dots from our dot plot up here so you can see it. So between our Q1 and our Q2, this data, so this data was 11, 11, 11, 12, 12. So the 11, just drawing the dots, the 11, the 11, the 11, and the 12 and the 12. So rather than drawing the dots, the box plot is just telling us that those 5 values are in that region. And then the other 25% in this side of the box would be those values 14, 15, 17, 19, 20. So 14, 15, 17, 19, 20. So I can see that those 5 numbers are spread out as compared to those 5 numbers. So we're just getting a feel for where our data is. All right, that's the box part. Let's get to the whiskers. So what we do next is we look at the smallest value in the data set, 6, and we'll draw a dot down here at 6 for the end of the whisker, and we attach that to the middle of the box. So that's the lowest number. And then the highest value, 28 minutes on hold, draw a dot there, and we connect it to the box. So those are the whiskers. They extend to the lowest and highest value in the data set. And again, we're just representing minutes on hold for customers. So down here, this would also be 25% of our customers. I'm not going to continue to draw the dots here, but those will be those 5 dots. And then up here, those remaining 5 would make up the remaining 25% of our data. All right, so then the last thing we do here is we'll talk about, is there an identifiable shape to the distribution? So not every distribution has a specific shape associated to it. This particular one does. So here's what we'll look at. In this case, the right side of the box is longer than the left, and the right whisker is longer than the left. So when that happens, you might be able to visualize the histograms we learned earlier. So if you look at Q2, this half of the data is in a smaller region, a smaller range, then this half of the data is all spread out. So you might be able to visualize the histogram. There'd be more data in a small region there, and then it's all kind of spread out to the right. So that shape is skewed, and it's skewed to the right. All right, so let's look at this little guy, my little box and whisker here. So now the left whisker is longer than the right whisker, and the left side of the box is longer than the right side of the box. So when that happens, the histogram would be in that direction in terms of being skewed. So that would be skewed to the left, skewed left. So I'll have some pictures for you of the shapes coming up. And again, not every graph will have an associated shape, but there you go. So that is our 5-number summary of our data set. And then the visual there is called a regular box plot or box and whisker plot.